okay. Looks like we're live. What's up? Intel software-defined silicone. Alright, let's see what that is. A Saudi's iPhone revealed hacking around the world. Okay. Simple AI, bank manager. That's pretty much what credit scores are, aren't they? Facebook shadow profiles. Okay, no idea what that is. Logging at Twitter. That could be interesting. Brain doesn't slow down till 60s. All right, let's see what we got. Let's see what else is here. Okay. Oh, bug bounty. This is interesting. Dating app with only one match at a time. Oh God. Why four Bloomberg engineers wrote another C++ book? Okay, that. I guess let's take a look at this. Software-defined silicone. Okay, let's see what he has to say about this. People are attracted to free software for a number of reasons: price, quality, community support, and available features. Yes, value free software is often found its ability to allow us to maintain our own systems. Sure. Any features in free software tend not to last long, and free drivers can unlock abilities of hardwares. Yep. Intel's upcoming software-defined silicone mechanism may reduce that control, though, by taking away access to hardware features from anyone who has not paid the requisite fees. Really? Okay. Okay, so they're basically putting some hardware behind a paywall. Alright. Why would you do that, though? Its purpose is to disable access to specific processor capabilities in the absence of a certificate from Intel saying otherwise. Okay, well, you bought the processor. Why do you need the certificate, too? Appears that the device on the bus that offers a couple operations install an authentic key or capacity activation. The certificate used to authenticate any request to enable features, while payload contains the requests themselves. Okay, so why is this even needed to begin with? Power cycle the processor should be either exceeds a threshold or mechanism would disable entirely. Presumably the intent here is to thwart attempted brute force attacks against the STSI gatekeeper, sure. Intel is clear about the purpose behind the new mechanism. STSI will ship features that may be interest to users but are unavailable unless additional payments are made. Okay, so it's trying to load a certificate. But why? Why is this even needed? It's unclear which features it intends. Okay. Price differentiation amongst its customers and attempt to extract the maximum revenue. In theory, customers with minimal need can avoid paying for expensive features and upgrade their hardware in downtime. So I'm guessing that they want to ship one single processor, but then lower or raise the capabilities of it. Yo, Snatch, what's up? This is really weird because the way you make processors is like the same for like the different models. The only difference is that occasionally some of the processors end up having higher cycles or lower cycles, and so that's where you get the different different selection and tiers. But ultimately, it's the exact same process. It's just essentially luck that determines whether or not you get a lower quality or higher quality processor. So I'm not sure what exactly this software thing intends to do. Taken to its extreme, an off-the-shelf processor might be unable to run anything more than demanding Hello World until additional licenses are purchased. So you need like licenses to run this processor? Are you kidding me? I don't know. I'm very, very curious what this is actually used. Rent-based models, yeah. So why would I rent a processor? software SDSIs could definitely come into Linux, indicating that the work is on track to be merged for 5.1.8. There's not a whole argument to be made against the acceptance. It simply provides another piece of functionality shipped with the upcoming CPUs. Okay, yeah, why? So it's basically being shipped in a Linux OS, the support. But why would you even want to have the processor to be certificate controlled anyway? It's absolutely weird. Okay, it looks like this used to actually be a thing. Intel upgrade. Low-end processors to have additional features unlocked by paying a fee and obtaining an activation code. Oh, so this is actually done before. Use an unlock code to upgrade your processor. $50 processor can have a 1 additional megabyte cache enabled. In order for the activation software to work, the motherboard had to have this chipset. One reviewer noted that at the market price, one could actually buy for only $15 more than the baseline. Let's see why they defended the program, actually. Processor upgrade program saves tearing PC. Oh! Okay, now I get it. Okay, so let's say you have... I'm guessing that you have base model... Let's say you have like two processors, right? You have low tier and then a high tier. And then you decide to buy low tier, right? And then one day you decide, you know what? I need more processor. I need more processor speed. And so instead of like taking apart your computer, ripping it out, replacing the processor, you can just pay to upgrade. I think that's basically what Intel is trying to do here. And I think this actually mostly works only for laptops. I'm starting to see exactly why they're doing this. So you can buy like the static version of the processor, or you can buy the flexible version. The flexible version gives you the option to upgrade, but would otherwise be more expensive than the pure upgraded version on its own without the option to upgrade. So I actually understand, like, for PCs that are very difficult to break apart, like the laptop, it makes sense actually to have this. But it wouldn't make sense to directly sell it to consumers. It would make more sense to sell it to PC manufacturers that eventually realize, you know what, you can actually upgrade the processor later on. So actually, I understand a little bit where Intel's coming from, because in a laptop, you would actually just need to upgrade the RAM is the easiest thing to do. Why would you never want an upgrade? You wouldn't want one because it's difficult to take apart. So for instance, if you've ever tried taking apart a laptop, taking out the processor is like really one of the hardest things to do. RAM sticks are easy; they just slide in and out. That's easy to upgrade. And so are the hard drives relatively, but the processor is like the hard one. So from a cost perspective, it actually doesn't change much for Intel. Like I mentioned before, the way you make these processors is, you basically dope the hardware in order to basically create silicon, right? And it's just the quality of the chip that comes out that determines whether or not it's like, low tier, medium tier, or high tier. But all the low tier, medium tier, and high tier all undergo the exact same process to be created. The only difference is like essentially luck, how it comes out, right? So what Intel could theoretically do is take like the medium tier processor and then call it a low grade processor by installing this software defined silicone. And so it will artificially lock it. And then for a fee, you can unlock it and upgrade. So I actually understand what Intel is trying to do here. It's like, hey, well, if people don't want to go out and buy a new laptop, they can just instead have this upgradable processor. And I don't think it should move the price of the laptop from a cost perspective, it doesn't change the cost for Intel at all. But they can actually sell it to, they can actually sell it to PC manufacturers. And then those PC manufacturers can, bump up the price by like $50 in order to allow customers the ability to upgrade. And so that's basically where this is coming from. So I actually understand it. It's not as sinister as people think it is. It's definitely an option, and I understand where they're going with it. but I would definitely like for a little bit more transparency from Intel as well. So with that, that's about that's 11 a.m. So let's bring my clients on. Let's see what's up. Hello?
I can hear you.
Yeah, I can hear you. Can you hear me?
Yes, perfect.
Great. Okay, cool. So catch me up on everything that you're doing. I saw you wrote me a little blurb. You had an issue with the wildcard issue, but other than that,
Yeah.
you're actually able to derive solutions now.
Yeah. Yeah, that's pretty much it. The thing of think clear about how to ask questions about if the next step will make sense to pursue has been helped me a lot, like, to try to derive solutions and like analyze inefficiencies has helped me a lot as well. Especially for all types of exercises.
Okay, cool.
And let me check other thing I said to you. Yeah, I took like those problems that I was talking to you on Tuesday, right?
Yeah.
And I did them again.
Uh-huh.
They clicked on my mind like, oh, that's pretty much like try possibilities, you know. And yeah, other than that, I think there are still a few corner cases I'm not testing yet.
Okay.
Which I think is not good because sometimes it's a corner case that can break like my code.
Mm-hmm. Yeah,
I'm trying to make sense of like where this is gonna die, as you mentioned.
Mm-hmm.
Other than that, I think it's pretty much it. Yeah.
Cool. So actually, can you show me some of the problems that you did that you thought you did well on and that you didn't do well on?
Sure.
Yeah, it's you in your practice diary, right? So.
Yeah, in the practice diary. I think it's a good way.
Okay, let's see. Let me bring it up.
Okay.
Cool. Got it. Okay. So 14. Okay, I see. So which one do you think you did well on? Which one you didn't do well on?
The compute valid IP addresses for me was like I was able to, as I mentioned, was able to arrive the answer based on the thing of the subset of like try to do the combinations based on that was much more clear to me.
Cool.
Don't know why I was not seeing this.
Mm-hmm.
Let's say that for the n-ary tree, your explanation helped me a lot, but I did again the problem. I visualized the entire all the possibilities of trees were formed, but I don't know. I think it's logical for me, right? But by myself, I think I would have a hard time. I will have like it'll take much more time to arrive in a solution as you
Okay.
it's so fast, you know.
I mean,
And
go ahead.
Go ahead. Go
Okay.
ahead.
Okay, I was gonna say, can you show me the actual work that you did, or?
Yeah. For the wild card, I did on paper. I can send you a picture, and because I don't know. Sometimes with pen and paper, I for those problems that I had more.
That's fine. Yeah, pen and paper is also okay. Just send me a a photo of it.
Just a second.
Yeah. Okay, serialized, deserialized n-ary. So from the 15th, that was when you did it, and then now you took an hour.
Yeah, I did this again as well.
Okay, cool. 15th, so it was right after our coach. It was right after coach says. Okay, so I should look at the 16th onward. Okay, got it. I feel like your practice, the number of problems is looking a little light, but.
Yeah, I feel the same. The same.
Have you been sticking with our schedule?
Yeah, I stick with our schedule.
Okay.
Cool.
Because I know
I'd say that
Mm-hmm.
only tomorrow. Tomorrow I had just to a little bit earlier because all of these days I was trying to put more time, all right?
Mm-hmm.
Because like to really make sense of the problem, and yeah, I took more time than we planned.
That's
and
fine.
yeah, tomorrow I felt like pretty strong. I need to sleep just a little bit more.
That's fine.
And
Yeah, these problems are taking an hour. Yeah, yeah. Okay, I understand why. And then they seem to trend better towards the end. You got a lot faster. Let me look at the previous.
Yeah. I would say that those ones off string was much more easier to me. Oh, I'll send you a picture because this one is on.
That's
whatever.
fine.
I'm
just looking through. I'm skimming through like the time it takes.
Take my cell phone.
Okay. Balance parenthesis. Okay, that was one we talked about. Computer valid IP address. 13. This was the 13th. Seems like okay. You did compute valid IP address before actually.
Yeah, and now since it was on the string chapter, I did again.
Okay.
That was a problem that really, I really was struggling in the past. And, yeah.
Okay, but it says
really
you came up with the solution in 30 minutes before, and then you did it again, and it's 50 minutes now. So I'm a little confused. Like look at row 43. I'm a little bit confused here.
43. Okay, compute. Yeah, that one I took 30 minutes.
Okay. And then look at row 50. It says you took 50 minutes here.
Yes.
Trying to figure out. You redid the problem. My question is, why did it take you less time before and more time now?
It said that the other time. Let me just take the day of this.
Yeah, I'm gonna highlight it just as a hey, this is something we need to look at.
Oh, I know why. This is because the other way I was doing, I was like falling in the same case as I went on the coaching session.
Okay.
And I figure out, well, that's actually not the right way to do this. For this other one, I tried like going the right approach.
Okay.
And it took more time just to fix those. I'm really not sure. Like, it took that long. 50 minutes. Yeah.
Okay.
Yeah, because and I draw the entire tree. Let me just send you the pictures.
Yeah. Go ahead.
But yeah, that is
structurally unique. Okay, serialize, deserialize. This is one. Did you do the deserialization portion of this exercise?
Yes.
Good. Okay.
I'd say that for the serialized part, I was easier to me than
okay.
on the serialized.
I see it now. Okay, for the first pattern, later figure out what was the appropriate presence of close. What I had 3 levels, designating for 1 level, just for sake of my creation. Okay, ground up work for 3 levels, sure. Able to identify the pattern where the action should happen, to traverse the element. Had trouble figuring out the end of where I should commit to, move, flexing on the first movement I thought. To do iteration with recursion would be easier, clever. They found in the video that I was wrong, and if I continue the stack idea would be is easier, yeah. You can do iteration, there's no problem with it. It's just that you're pretty much gonna just use the stack most of the time. Because
I was confused. Oh, go ahead.
No, I was just say that it's simply easier to do a stack because stack and recursion are pretty much interchangeable. So that heuristic should have immediately let you to think to that one first. That's really what I want to say. It's just that if you know that heuristic is like if you remember like you can write things iteratively or recursively, but the thing is that with recursively it's essentially a stack. So your mind should have made that connection. So that's it.
Just a minute. I'm just sending you the pictures.
Yeah.
Yeah, just one thing I found pretty good. That was one problem. I think is to reverse all the words in a string. That one I follow. I think was like one of my best problems I did because I follow with the most naive approach, and then I was able to identify like a lot of inefficiencies and like derive like the best answer upon this.
Okay. I think this is a relatively easy problem, isn't it? Let me take a look.
But it is, but to derive in the most optimal approach.
Yeah, as long as you get as long as you get the what's called the process down and you feel very comfortable with it, that's a good sign. And, everyone starts somewhere, so yeah. Let's take a look. Reverse all. The words in a sentence. It's difficult to solve this with one pass. Okay. So your solution works fine. EPI has an optimization to use only one array to do the work of the reverse, while I use two. So next time I will think more now. Not yes. Okay, fair. Yep. I will say that this particular problem is a little bit harder, a little bit trickier, but it's not that bad.
Why do you say that? Because of like that one pass?
Mm-hmm. It's a little bit trickier. It's not terrible, but it is pretty obvious when you think about it and break it down. So
yeah, for sure, it is.
Okay.
Yeah. Let me just check the wildcard one. I send you the.
Cool. Let's take a look. Let me download these.
Okay. There are 4 pictures. I think the wildcard is here.
Okay, cool. Okay, split. Yeah, let me save the image actually. Okay. I'll select Bob is out, split by empty space. Okay, yeah. So you tried splitting empty spaces. That's the easiest way to do it. Not allowed to use .split. Okay, ALISC. Construct the string array of characters. Traverse the array from element. Okay, element. Traverse the array forming words for every element. If the array string, if it doesn't equal space, word plus equal. Yes. Okay. So basically, you iterate through a string. You basically just iterate through the string. Yeah, actually, essentially what you're doing is just iterate through a string and then create a new string. So yeah, that's basically what happened there. You don't need to actually create a new array with it, but it's fine. So the question now just becomes, how do I do this in place? So no, I think it's fine. Definitely would be nice to get an optimal solution, but okay.
Hold up, I'm just trying to send you the wildcard one. It's on the practice sheet if you have access. I was trying to put this on a TXT file, but I think I'm gonna break down this practice sheet because it's getting too long. I'll break it by chapters.
That's fine. Let me just open up your last photo and I'll look at the
A little bit messy, sorry about that,
okay,
but
it's fine. IP address problem, groups not greater than 2s. Use nested groups, sure, 192. Okay. You start with 1, and then you drew the tree for that. Okay, you drew the tree for that. It's the idea, divide into different chunks and validate the current chunk. Okay, yeah, so this is basically what you basically did. Okay, 1, 9, and then 1.92, yep. And then you could do 1. Okay, I see the way. Yeah, that's basically right. I don't need to see much else. I think that's correct.
Just a minute. I'm gonna just send you the last one because I think it's very important.
Sure.
Feedback.
Generate IP address. Valid count 3 should be dot count 4. Yes. Okay. This is you made a few mistakes here. No need to validate. You could validate here. I would validate at the end. I would validate at the end personally, but it's fine. I think that.
What do you think? What do you recommend?
So let's see.
To go better.
Dot count minus. Okay, -1 chunk index, a possibility of copy. I mean, this is fine. If you feel like you need to validate here, you can validate there. Actually, it's not terrible.
Okay, I send you the TXT of the wildcard one.
Okay, your recursion is a little messy in my opinion. First of all, I would have yeah. Oh, I see. Yeah. That's what you mean. Yes, Correct. So you would want to validate before you would go into the recursion. That's correct. Instead, you do it after the recursion. So it's a little.
Uh, I have one question. I was like, the way you did, you validate like before you go in the recursion.
Correct.
But I was not checking. Okay, if I validate the second chunk like before pass to the recursion, last iteration it's gonna be invalid. I was not figuring out how to do this in only one validation. If you understand what I'm trying to say.
Yeah, I see what you're saying. Is that instead of validating the entire last possibility, once you've built it up, you just build it, you validate it before you do the recursion, and that's fine. I personally just separate it because for what like one, it's our like the valid chunk. That's something I just like separating the steps out for. It's just for me, it's much more discrete. And of course, like there's always an optimization that can be done on that. But the solution I provide to you was just really just, hey, yeah, this is the way. It's easy to really think about because you have the recursion, you have the validation step, and then you have the final commit step or whatever. So it's fine to validate it there if that's what the book does. And if it clicks with you better, then that's fine. But yes, should dot count equal 4 and index equals that, and then validate before you go in. That's perfectly, yeah, that's fine. I think that's better to do. I just did the dot count and index length. So, yeah, so your IP address definitely needs a little bit of work, but I recommend thinking that into like discrete portions of, okay, here's what I need to do at this chunk or at this moment in recursion. Here's the recursive, and then here's the terminal case. So in this case, the dot count equal 4 is the terminal case. That's what you use to exit. And then before that, you have what you need to do at the node, which is iterate through 1, 2, or 3, and then validate that chunk before you recurse. That's really all this is.
Okay.
Does that make sense?
Sense.
Okay, definitely needs a little
And
bit.
the last one. Okay, go ahead.
Oh, wildcard matching. You said that this was in the practice sheet?
That one was isn't a practice. No, I sent you the TXT for this one.
Let me see this. Yeah.
That one actually was there is the same problem, I guess, on grokking with the same name.
Cool.
But that was one with the mock I did with a friend of mine, and I said, ask any hard question like with subsets, please.
Okay.
That was one of them.
Cool. So given an input string and a pattern, implement wildcard pattern patching for support for So like a regex for so single character star. Okay, perfect. So you're trying things out.
And that one, just one remark about this. That one like the general case of using the star, because I don't know how you say that, star, interrogation mark and star. Right?
Asterisk, yeah.
Asterisk, yeah. Like there was, I guess one edge case. That one was the one of the edge case thing. Because in the third example I was trying to generate like all possible combinations of this asterisks. On the last one, I think was where my solution break, So yeah, that one I would say that was not that good of a question.
Okay, that's fine. That's fine. Okay, I gotcha. Other than that, yeah. So what do you? Okay, so letters are equal, traversing, criteria. Else, yeah. I'm curious how you handle the star case. Index recursion. Nice. Good. Okay.
Basically, I was starting a recursion, but yeah, the thing was, if I have like another start case, I fall into this loop, of I need to compare with the next. Because for example, if I have one end that is valid, let me say one letter that is valid on the middle, but in the pattern, this letter is the last. I need to compare with other letter to see if the end matches. So that case, I was not. How can I go back on the recursion and try the other way around? That was a little bit confusing to me.
Okay.
And actually, that was the mock interview I did.
Yeah, so basically, the way you think about star is, okay, well, let's say there's, like, what are the different ways that I can use this? In this case, you have like, you have star and then you have star A, right? So the way I would think about this is like star just represents wildcard, right? So what really matters is the letter after it. So this A, right? So what I would do is in the other string that I'm matching against, look for all the possibilities of A, and then continue in each one of those places. And you just need one of those to come back. So that's basically what this is. You just need to be more cogent of this case. That's it. Does that make sense?
Okay.
Because the thing is that it's not just the next letter, because this could be any, because this star could also have hold A in itself.
Yeah.
That's it. Other than that, I think your answer's right. Is like outside of that, your answer should be technically be right.
Yeah. I think just the end part. I was not connecting this last thing as you said.
Did the interviewer tell you that, or?
Yeah, my friend told me. Yeah, he said just that one part to finish. Yeah.
Mm-hmm. So in other words, what you failed to do was really just see all the different ways that this could possibly be used.
Yeah, that was basically this.
Yeah.
And we decided it was like 35 minutes in, and I said, man, it's not that I'm giving up, but in a real interview, 35 minutes is a lot. I'll try this later.
Yeah.
So yeah.
So I'm not sure how to generating the examples. You just need to test against every single example. That's basically that's really it. Like, because you have the examples here, right? So all you have to do is really test against the a proper example. So like what is like the expansive case, not just like the basic case. What other solutions can be used here? Let me see if I can give you like a structured heuristic. I would say that the most structured heuristic I can think of is like, okay, now that I've solved the base case, what are some of the crazy cases that can come out of this? So in other words, like if let's say the test string that I was testing against here is A, let's say A B A C A D A E, right, and then A. So this is like where your algorithm would break, because you need to test this A, and this A, because this could all be represented by wildcard.
Yeah, that makes sense.
Yeah. Yeah, it's this any that's killing you, actually. Now that I think about it, it's it's really hard for me to come up with like a hard heuristic for you to avoid this mistake. It's more so just like, okay, now that I've solved, I think it's just taking the next step, like what are the crazy cases?
Yeah, I feel like the first time I did grokking, it's the same thing of like the intervals type of exercise that you need to consider like all the 5 cases, I guess 5 or 4 cases, and I was trying to make sense of the same way,
Mm-hmm. The best way, I can't really give you a methodic way of coming up with crazy cases, other than just like maybe built off of the base case. Maybe it's hard for me to say, because when I look at this problem, all the wild card is just like, oh, okay, well, it could be any string, so which means it could be literally any.
Yeah.
So it's hard for me to describe exactly how to think about it, but yeah.
Sure. Other than that, I think those are the ones that really catch me up.
Okay. Yeah. Other than that, I think you're just making a little bit more progress, but not as much as I had hoped. But it's okay. These things take time. So. Okay. With that, let's actually do a problem, and I will.
Okay. Okay. Yeah. Go ahead.
Yeah, I don't really. I think that right now, I just want to see you do more problems. Honestly, and just get a little bit faster with these things. But that'll come with practice. So I think upping your practice would be better. So let's see. Let me open up the problem sheet. Okay, what other problem? Okay, we can do it with the red tape, blue tape problem, actually. This should be fine. I definitely want you to have a little bit more practical recursion, but, yeah. Oh, wait, no, this is good. I can actually do this one. This one with you. Alright, I'll give you actually this problem. This problem is actually a little bit more interesting. Actually, yeah. Alright, let me make sure the timer's showing. Okay, when we go to the question, where's your question sheet? Okay. Alright, here we go. So suppose I gave you a block of text and a set of strings. I want you to find me the shortest string in the block of text that contains the set of strings. So let me give you an example of this. It's a little bit confusing.
Sure.
So let's say I have a string 1, 2, 3, 4, 5, right? And the set I gave you is 2 and 4. So the shortest string here that would contain 2 and 4 is this string here, 2, 3, 4. Right? And the second example here is like if I gave you 2 and 4 again, but with a different string, the shortest string would be here, 2, 3, 4, that contains 2 and 4. And then 2, 1, 2, 3, or 5 would be the shortest string that contains 2, 4, and 5. Does this make sense?
Yeah, that makes sense.
All right, cool.
One question about this. On the third example, the string must the shortest string just to have to contain those 3 elements, right? So it can be 5, 5, yeah, all right, in different orders. All right. All right. Let me just check one thing here. So given this first example here, the first thing I was thinking to do, is to traverse through the string. Let me just check how I would do this normally. Okay, checking this first one, if like this first word. First of all, it's gonna be given a string. So the best way to, I will need to check each word. All right, that's one problem. That one question I need to think, right? So, I think the best way is to actually break down first for me to analyze better. So, okay. So imagine that I broke it down, and I am analyzing those words separately in an array of words.
Okay.
Okay. So I'm first going to check if this first element here is equal to anything I have in my set. In this case, it's not going to be equal to anything. Then I'll move to the next. Here I found a 2, which is equal to one of my sets, one of the words inside my set. Then what can I do is, all right, from this 2 here, I can try to check. First, I remove this to the set, and then I'll try to find like one of the words that correspond to the 4. So I'll go to the next, that is 3, not 4. Then I found a 4.
Okay.
And and now I remove from my set. In this case, while you're traversing to those words, I can have, let's say, a counter, right? And in this case, like I have to return like a 3, because this counter is going to be there's like 3 words that I can find, all of the ones inside the set. But let's say that this is the shortest. I think yeah, basically, let me see if that idea is gonna work for the second example. Then I can work on like defining the sets for this approach. So yeah, the same thing. I'm gonna receive a set. Yeah, it's the same set actually. Yeah, so I found this first one,
Okay.
2, and yeah, from 2 I'll try to find if I found one of like the other that is inside the set. That is in this case is the 4.
Okay.
So I'll traverse to this to 1, 2, 3, and then 4. Incrementing a counter, and then when this set is empty, I just return. Okay, that's pretty much the other case.
Okay, but the thing is that you didn't find the shortest string.
Yeah, for sure, you're right. Because there's like a shorter string that is this 2 right here, and this 4 right here. You're totally right. Now, let me check. What can I do is, right. Like just a very naive approach is to start from every letter. So I start from this 2 here. I mean, every letter, no, every word. Start from 2, and then the shortest one is gonna be 1, 2, 3, 4, 5. Then I start from 1, and the shortest one is gonna be 3. Okay, so that's basically my naive approach.
Wait, repeat that.
I will start from every word. All right. First, I'll convert this the same way I did here.
Okay.
Like to different words, right? Imagine that it's converted in an array of different words.
Okay.
And for every word, I will start a count like where it is.
Okay.
Let me just put in better words. I will traverse the entire like set of like the entire list of words, trying to remove all those words from my set.
Okay.
And so if I have the starting point in this 2 here, this number is going to be, as I mentioned, it's going to be 5, right? And yeah, then I will start from 1.
Okay.
Doing the same thing. And in this case, it's going to go, yeah. 2 is the first one I will remove from my set.
Okay.
Let me just put the original set here. At every iteration, I will restore the set.
Okay.
Maybe, yeah.
Okay, I understand what you're doing.
And yeah, so basically that's it. And then in this case, I'll find a smaller one that is 3, you know? So that's the naive approach for this. Let me just write down here in a very simple way. So, yeah. Break the string in words in a list of words, and every word in the array in the list. Try to find all of the words in a set from every word in the list. Verse the list, and if found one word that in the set, remove. Okay, once the set size is equal to 0, I have to store as one possibility. So I will compare like the shortest the shortest string of block. So the shortest.
Yeah, okay, you're describing the naive solution. I don't think I need you to write out the pseudocode for that. Mainly it's just a crutch for yourself if you need it, but that's it.
Nice. Now, one inefficiency here that is pretty clear is that we have to iterate this n times for every element, which is going to be a complexity of O to the n squared.
Okay.
And let me see if I can do better for
Yeah.
on this. So going to this first example here. Okay. Let me just check. If I found this first one here, that's this one, I can move ahead because it's nothing inside my, it's nothing like it's in my set. Then I'll move to the second one. In this case, let me just take the second example because there's a better example, I guess, or to see that there's a smaller sequence than what is obvious. Okay, so I do the same thing. I verify this first one. Yeah, it's inside the set. So let me just see. From here, I can check. Yeah, I can check like. Can check if I found the other elements from this one. So yeah, I'm gonna go to 1. 1 is not inside my set. Then I'll move to 2. 2 is inside my set. And then I can move like some. Yeah, but just one thing here. I just need to keep track of like the words I visited. So for example, let me say, let me just check if I found a 2. And now I found another 2, but this 2, yeah, which means that is a word that I already visited. So I can start from here now. And then, yeah, from this 2, I go to 3 and then 4. And yeah, actually I found another one that is inside my set. And yeah, now that's, yeah, those are the letters. Like the letters that I visited is the same size of the ones in my set, the same size of elements in my set.
Okay.
Okay, that makes sense, but let's say that I can have an even shorter string again.
Yep.
No. Let's say 4.
Well, it's kind of hard to
Three.
set. Let's put like let's put 5 in here just to make it a little bit easier, and then let's say it's like this. That way you have the separation. But all right, what do you do now?
Yeah, in that case, I don't have the 4, right? That is inside the set. So, let me see. So yeah, starting over from 2,
Okay.
I'll move ahead, marking this 2 as visited in some sort of place.
Okay.
Then I move ahead. I found 2 again, so I can make the starting point from this 2. Then I move ahead. Out 5, 3, 2.
Why do you need to mark? Well, my
Yeah.
question is, why do you need to mark 2 and 2 with 2 pointers?
Because I need to define the block of text that contain this set of strings.
But you need 4.
So I can have the reference.
But you need a 4.
I need a 4. In this case, there's not a 4.
Okay, so then why do you put the mark? So what happens if I put a 4 here? Would you still do the same thing?
I'll find a 2 here, you
Okay.
know, so it's going to be my starting point. And from that starting point, like I can just record like the chunk where it starts, so I can return you the block of text. And I'll visit the next word, and 5 and 4. So 4 is the other. So I'll put it inside here. And my verification, like the ones I visited, is the same size as my set. So in this case, I will return you like this chunk.
Sure.
This piece of the string here.
Okay, that works. You will eventually find the chunk that works, but that only works because you have 2 elements in the set. What happens if I give you 3? How does your solution scale up?
Let me see. Yeah. Let me take the third example then.
Sure.
That is the one with 3. Put down here. Okay, going the same way. First, I found a 2 here.
Okay.
I can mark this as found,
Okay.
as like in a structure.
Sure.
Right? And yeah, let me see. Then just marking a starting point of the chunk on the 2. Then I'll move ahead 1, and then I found another 2, which I can update my starting point to like split the block of the string. And yeah, and now I'll traverse to the next, that is 3, and then 4. So 4 is inside one of the elements that I'm trying to find, and then I'll put this as found, you know, and yeah, that is a thing. Because I know that this is the start. This is the start. If I follow the same logic that I was doing, I would, yeah, I cannot like go back this pointer to the 4. I need to keep going until I found a 5, you know.
Sure.
And like put it on my string. So, yeah. And since the size of this is the same as the set, I will consider this chunk as valid. Yeah, the question is how can I keep track of this start? Basically, I can track which one is the start. You know, yeah, but that doesn't make sense because if I have a 2 here,
this would be
a shorter.
Yeah, keep in mind like, and these can happen in any order. Yep.
Yeah, that thing I just figured out here. Because you see that one that I put in bold is actually smaller. So let me see. What can I do here? Yeah. Let me just go back from the beginning.
Okay.
I can, let me see. I first need to define, basically, like, I can check the shortest piece of things that have what I want. So let me just check. The first one that it's going to contain is this 2 right here. It's going to contain 1. But just a second, because this is one problem. I did this one very, very much like this one.
Okay.
Yeah, then I'll move ahead, and here I can find another starting point.
Okay.
And then here I will go to find a 4 that is inside my set, and then go to 5. Right.
Well, what determines whether or not you move up one pointer or the other?
You said?
What determines whether or not you move up one pointer or the other?
And where will you if I found condition, if I found something that is inside my set. That's what I was thinking.
Okay, so you said you start off with 2 and 2, right? And then you start out 2 and 3, and then 2 and 4. How do you know which pointer, this one or this one, to move up?
Yeah, that is the point. If I found, actually, let me just see. If I found an element that I already visited, in this case the 2, then I can go to the one that is furthest.
Okay.
You know.
Wait, what? So, wait, repeat that.
If I found one of the elements, in this case 2, that I already visited. And I can go to the one that the most right one on the string.
Sure.
But I need to just verify if that will help. And then I can keep traversing. Then because the question is now, I'm just trying to fix this one corner case I just put here. Because if I found a 4, I then can mark this as one of the visited. And then if I found a 5, all of the elements that is inside the set, I already visited. So basically I would stop, But what I'm trying to see here is that we can start now from 4 and then move ahead, and then we'll find a sequence that is smaller. That is the point, I'm trying to.
Okay, I see.
The question I'm trying to answer.
So basically, you only move up so the rule that you're saying for moving up the left pointer is based on whether or not you've seen all the numbers in the set or words in the set. Is that correct?
Yeah, that is correct.
Okay. Okay, that's fine. I think that does work. Let me see what your pseudocode is. I'm actually curious to see if you understand the idea.
So the rule set I was trying to define is that, actually, let me just write down the pseudocode as you mentioned. So traverse the elements of the string. Because as I mentioned, I'm going to break down this to be easier to find elements on the string. If the element is in the set, what I'm going to do in the given set, in the given set, I'm going to remove from the given set. Remove from the given set. Okay, and and then put in the visited set. All right. And there's a case if the element is in the visited set. If the element is should do then is update the start to the current element. And I mentioned, because if I found a 2 here, I have to start again here, then move ahead. And then once there is nothing else on the given set, I should that is the thing.
Okay, so you're traversing the element. If the element is in the visited set, update start to the current element.
Yeah, update the start.
Okay, got it. If the element is in the given set.
Given set, the one that was given.
I see.
On the.
I see what you're doing. Okay.
Yeah, but the thing is, if I cannot. In that way I can. If the given set is empty, I can basically finish this. But technically I cannot do this because there's smaller chunks.
There could
be. Just trying to see a rule set. Oh, go ahead.
I was gonna say this already kind of doesn't really work, because what if I stick something in here? Or should I say it's 2 and it's what if I stick something in there? Then your thing kind of fails. Do you know why?
Just let me see. Right here, right. First I'm gonna traverse, trying to find I start is where I found the first one on the given set. And yeah, 3 is not inside
Sure.
the visit set, so I can proceed to 1, then 2 again. And then I can start from this 2.
Okay, but that's fine. But what if I put, like I said, what if I put in a 5 here?
Okay. Oh yeah. A 5. So I'll have 2 and 5
as visited, but then your algorithm says you're gonna move up this to here. So then you'll abandon the 5.
You're right. Let me just check this. Let me just try to see what can I do by walking through it. Yeah, 2 and 5. In this case I just need to find a 4. Be one of the valid sets. Yeah, actually that doesn't make sense. That doesn't make sense. No, yeah. Because what I was thinking here is, for example, I found a 5 that is inside the given set, and then the only other, let's say that I am like excluding from this given set, the only left element for me to find is the 4. And yeah, that's one possibility. What I was trying to think is start another reversal from the second element, and from the second element, check if I can find all of the others. So I found the 2 and the 4, but still, this one is not the smallest one, the smallest sequence,
Yep.
And then yeah, I start. This boils down the same.
Same
approach,
thing, yeah. I don't think you're gonna. I think I know what's wrong, but I'm going to let you struggle through this a little bit more. And then, but I'm going to say right now, just as a hint, I don't think you're being very logical about this. And we'll talk about it later. But I'm going to let you struggle with it for another 5 minutes, and let's see what's up.
Okay. So basically, I have the given set. That was this one: 2, 4, and 5. I need to find the shortest string, like the shortest block that contains all of those strings.
Okay.
Okay, the first naive approach is that from every string I'll try to find all of the others. From every element I'll try to find all of the others. But yeah, the inefficiency is that I'm gonna be moving like this part, like n square times. What can I do is try like to form those groups. See, how can I form these groups? I can put 2, 5, and then yeah, 2, 5, and 4. That's one group. My question is the only question that I need to answer to solve the problem is how can I? Okay, that's one possibility. How can I consider like the other possibility?
Okay.
The more clear thing I can think here is that let's say that start from the next one that is visited. So what I mean by that is start in this case from 5. Then from here try to find like the set of the strings. So this is going to be smaller, but there is an even smaller group. So what can I do is start from the other that was found, that is this 2 here, and in this case we're going to found 4, 5. That's a bit smaller. Then we can start from the other element that was inside the set, that is the 4. In this case, it's going to be the optimal one, the smaller one. The question is, how how can I move this start once one possibility is made? Okay, so have to, once all the strings, all the elements found on the of the given set, that I need to try the other possibilities.
Okay.
Possibilities I, starting from the next position that is inside the string. That is, in this case, is going to be 5 here. So I have to start from the next valid element this set. Okay, so I think that's basically this.
Okay.
If I do this, I can just, repeating this over and over again. And here I can like compute the minimum size. Size of the group. Like the current and the current size and the older size. Let's put it like this. Okay. That is the moving condition from the starting point. Once I found all the given elements in the set, and then I should move my starting point to the next valid element.
Okay, so let's see what you got. So once elements found possibilities by starting the next valid element in the set, and then compute the minimum size group. Okay.
Yeah.
Okay, so that's better. That's better. Yeah. So.
But this is gonna be go ahead.
Okay. So you start from the next valid element. All right, go ahead.
Yeah, this is gonna be traverse all elements in the string, and time I'm gonna do this, we'll go into
okay,
the current element. In the set, I should like to record current element, and once all the elements are found of the given set, I should start from the next valid element in the set. And this condition, and then I will compute this, always computing like which one is going to be my minimum size group, and then in the end I can, based on the indexes, return to you like the group that corresponds to like the smaller one. That was basically the idea.
Okay, I mean, there's still some inefficiency here, but it's I want to pause here because I think there's some things we can talk about. I think you're on the track. You're on the right track, though. That's the thing. That's good. So tell me what you think you did well and what you think you didn't do well here so far in the first 30 minutes.
We're gonna copy the timestamps here?
No, I want you to tell me like what you think.
Okay, what I think. The first part I think was good, like the naive approach. and I was able to recognize the inefficiencies.
Uh-huh.
But the thing that I didn't like at all was the fact that when I started to see that was going to nowhere, you know, like in this thing of changing the start from 2 to the this other 2 here, it took too much time to me to think about an example. Okay, and if, as you mentioned, like if you put a 5 here, now I think that took too much time. It must happen much more quickly. So once I see, okay, let me see if I put a 5 here. Yeah, the time I took to like derive this condition of, yeah, once I found one valid group with all the elements in the set, I can try the other. It took like too much time at all. Also,
Okay.
Well, those are the 2 main points that I didn't like at all.
I would say your bigger problem is that you kind of, I want to say you just kind of abandoned a little bit of the logical, illogical thing. So let's actually, I put some notes here, but I think it's easier if I just show you exactly what I'm talking about. So let's start with your naive solution, right? I think it's fine. You break the words into a list. For every word, traverse the list, and then you try basically essentially what you're saying is you're trying every single possibility of the strings, right?
Yeah.
And you start with the basic example here. So for every single word in the list, traverse the list. If one word found in the list, remove. Once the set is equal to 0, then you found the shortest string. And you just iterate through every single, word in order to do that. And that works fine. And then you identify the inefficiency of, oh yeah, we're trying a bunch of different blocks that aren't unnecessary. So what if instead I try... You basically go to the idea of pointers. So the question then becomes, well, what will you be pointing at? And this is like the start of your trouble, actually, because you never answer that question. So let's go back to this, right? So when you decide to make that jump from trying every single possible word to using pointers, the question is now you need to know what you are pointing at. How does pointers eliminate the inefficiency in the previous problem, in the previous solution?
Yeah. Should be pointing to like the first one valid in the set.
Okay.
Now it took too much time to me to realize that.
If you literally, you basically, what you did is you came up with a naive solution, you identified the inefficiency, but you never said how your optimization addresses the inefficiency or what you need to do with it. That's the logic.
Yeah.
But if you realize this is like what exactly you need to point at, then it becomes a little bit clearer.
Totally. I would solve this much faster.
Yeah. Exactly. So the question you need, so this goes back to logic. It's like, how does your new solution address the inefficiencies of the old solution and make it better? It should build on top of it. In most of the time, it'll build on top of it. Other times, it will not be. But you should at least try to think down this route. So in this case, if you had known, okay, well, I'm trying. The inefficiency is that I'm trying a bunch of different shitty solutions here, right? And I'm trying a bunch of different places that don't need to be tested. So instead, what do I just need to test? In this case, you only need to test at the valid locations. Or in this case, at the locations where the elements, where the let's say the at index is in the set. That's what you should have been thinking. And then you could still you would still be able to apply it here. So instead of trying to traverse through every single word in the list, you just now traverse at all the locations at the index. You see how like that just immediately translates over?
Yeah.
And then you can still do your whole your naive solution, and then you just repeat this process again. It's like, okay, well, what is the next weird thing that I'm doing? That like what is the thing that I am still being suboptimal about?
Oh.
And so now it's like, okay, you just expand the list. The next thing, well, actually complete the exercise with me, because this is essentially where you got to, right? Because you have like tried all the elements in the given set. Yeah, that's basically what you got to. So let's continue like trying to use this heuristic of building on top of our naive solution, So now that we know that we only need to test at locations where the word that we're looking at is in the set, what's the next thing we need to do?
Let's say that is to kind of know where like the elements of the given set are. Yeah, and based on that, for example, I know that that's an element that is inside my set, and that's another element. Oh, this is like different. Let me see.
I would.
And-
Okay. So let's say you did find the. Let's play that out.
Uh-huh.
You said you need to look at the positions of all the elements in the set, right? What would you do?
That's one direction.
Okay, that's
Yeah.
one direction. What would you need to do in order to accomplish this?
Yeah, after doing this, I would. Oh, what I need to do to accomplish this, right?
Yeah.
I would need to traverse through all of the elements,
Okay.
and let me just think logically
Yes.
about this.
How do you get all the locations of all the words in the set? Yeah, go ahead.
What I was trying to think is to make this like easier thing for me to work, like, because if that was given to me, find like the shortest, let's say, substring that contains all the elements is much easier, you know. I was trying to think. I'll first. I can like after doing all of. I'm just gonna go in the direction I'm thinking that is more logical.
Sure. It's not logical. It's very simple, actually. You don't need to think logically. It's just a way to help you progress through the problem. But this is a very simple ask. You don't need to overcomplicate it.
Okay. So. Yeah, like the idea I put here, like if I found like this first one that is in the set,
Okay.
and then I'll move to the other that is like inside my set as well.
Okay, first of all, what is your objective? What is your objective? I think you're confused. What is your objective?
My objective is to find like the minimum, the smaller portion, the smaller window in the
No,
string.
that's not what we're doing right now. You skipped some steps. Let's rewind what I just said. So I said, hey, we only need to test at locations where the word is in the set or the element that we're looking at, right? You said that you wanted to get all the locations.
Oh, okay.
So this is what I mean.
So-
Write down what your objective is. I want you to write down.
Okay. Objective is the words that are in the string
Mm-hmm.
and in the set and in the given set, find the smaller group containing all the ones in the given set.
That is, you're making. Okay, stop. You're making a big jump here. Let's look at this. You made a very big jump. Right now, we're at the part of, hey, instead of looking at every single word, I'm only looking at the indexes and locations. Right? And this is a jump because, obviously we need to find the smaller group containing all the ones. But this is just restating whatever we have here. We're trying to do this step by step, and you're trying to do this all at once.
Okay.
This is the difference.
Just to see one thing, you're first trying to find all of the indexes that contains the words in the set. All right. So I will first go over this string here and identify all of the words that are in my set.
Okay, sure.
Like thinking about a step by step. So I'll put a 2, then actually maybe record its index.
Okay.
So, and then let me just put in a very simple way. And then I'll put a 4, then a 5. Now I know that all of those words are inside my original string, and they are inside my set.
Sure.
Now I need to verify inside of this, which is like the smaller, let's put window, right? Or group.
No.
Yeah.
I mean, here's the reason why this is not going to work. First of all, you're making this jump again. You're not thinking logically. You're making this jump like, okay, you found all the words inside of the string. How does that help you?
It does help me because I don't need to traverse through words that are not in my set. I was thinking.
Okay, so then, so now you don't need to traverse through words in your set, but you already have the words in set that you need to look at. These two are not fundamentally different. Like, what's the difference between this set and this set?
Oh yeah, it's because there's one more 2 here, an extra 2.
So what? Okay, this is extra 2, but then again, how does this help you? What get to the next step that you need to do?
I mean, yeah, just let me see if that works.
No, you should know.
No,
you should already know.
If that's gonna help. If is that gonna help?
No. That's the wrong thing. You're saying if it's going to help. That means that you're trying random things. You notice what you just said there?
Yes, I said this.
Yes. You said if it helps, which means that you're not thinking about the objective or the next step that you need to do. You're trying random ideas.
I need to think about like the next step, right? And then
Right. So let me rewind this, because this is what I called you out on. You said, "Oh, I need to find the smaller group contain." This is what you said, right? You want to, in the words that are in the string and the given set, find the smaller group containing all the ones in the given set. And I told you this is not the step by step. And instead, you are still fixated on this objective and still trying to do random shit in order to try and accomplish this. I'm telling you that this is the wrong thing to do, and you still plowed ahead.
Okay.
So let me rewind it, and I'll show you exactly what the right thing to do, and I'll explain the difference. So, right, let's look back at what we did here. Now, only test at the locations where index is in the set. The next thing is that you should be asking yourself is, what are all the locations?
Not all of the words. Okay.
That's the next thing. It's like I'm not given these. I only have the set, and I only have the string. You say only test at the locations. How do I get the locations?
Okay. How do I get the locations?
Yeah. So I'm gonna do the next few steps for you, so you can understand like how I think about it, and how I'm trying to get you to do. So if I want to get the locations, then all I need to do is traverse through the string. And then for if the element at the index is in the set, record the location. So then what I end up having is going to be like a set of like 2, which is going to be at, let's say 2 is going to be at, 1, 6 or something. And then 3 will be at 2, 5. And then 4 will be at like, let's say 4. Like, that's not necessarily what's happening here, but you understand where I'm trying to go with this.
Yeah. You're marking like all of the locations of the words.
Yeah.
And then, you did the step by step. I was jumping.
Exactly.
From this step of marking. Yeah.
Because if I need to test only the locations, where are the locations? Like, there's a bunch of different ways I can do it. I can just, like, still iterate through the string and then just check to see if it's in the set. That's one way of doing it. The other way is, like, literally just coming up with it beforehand. But the reason why I'm doing this is so I can show you, hey, this is, like, there's a question that needs to be answered here. So let's
the locations.
Okay, so let's say I have locations now of all the different locations. I can just put this all into one list. It doesn't matter. But that's still like I'm still iterating and I'm only trying it there. It doesn't really make a difference. But the next thing is to address our inefficiency again, which must be okay. Well, what I'm doing is I'm trying to iterate essentially through the words again, right? So in this case, what would happen is that let me go here. Is that now I've seen like my 2, 3, 4, 5. I'm just going to try 2, 1, 2, 3, 4. I'm going to try 2, 3, 4, and I'm going to try 4, 5. I'm basically just going to iterate through these chunks over and over and over again, right? So
You're not starting from, it's not needed. Yeah.
Yeah, even though I'm starting from these indexes, it's still not helpful. The inefficiency is that I am still just doing 2 loops, effectively. Do you understand? Now do you understand, like, why I'm, like, how this logic plays out? Like, even though I'm not doing 2, 1, 2, 3, 4, 5, and then growing it out each time, now I'm only doing it here, but it's still inefficient because I'm still having to traverse through every single element. And the efficiency is that I am still traversing over and over again on the same elements. So if I do, like, 2, 3, 4, 5, I'm still iterating over 3, like 2, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5. I'm still iterating over these same elements. So the next logical question is, how do I avoid doing this? How do I avoid this inefficiency of traversing over the same elements?
Now I think that is like. Can I try to answer this?
Yes,
question?
I want you to pick up from here. Now that I've set the road up for you.
Okay. The way I will try to avoid this is basically try to find the smaller group.
How? That's the objective. Remember, we're trying to. The problem statement is, I want the shortest string of text. But the thing is that, how do we get there? Your objective, like, this is like the top line, the problem, right? But all you've done is restate the problem to me. I want you to tell me what the next step is.
Okay. Thinking about this inefficiency.
Okay.
So, I can try, let me see. There's a 2 here. Let me check. I can set this as visited and hold up. I was trying to see in this case here, for example, it's going back to the same inefficiency what I was trying to do. Yeah, okay. From like 2 and 5. Yeah, okay. I think that's a better way. Okay, so I can have a starting point that is this 2 here.
Okay.
And yeah, I would the thing. I would traverse through, like, this 2 is already inside my like the valid elements, let's put it this way, that are the ones inside the set. And what can I do here is, just let me put a case here. If I found a 2 and a 5, I just need to find a 4.
Okay.
I found a 2 again.
Okay.
And just shrink this.
But you said you need to find a 4. Why didn't you shrink it?
Because I found, like, another element that I already visited.
Okay, sure.
And I would start, but not from the second, from, like, the next one that is valid. But that's a loop of.
Okay. I'm going to pause you there because I think here's another thing I want to talk about. Is that you're over-optimizing already. Remember, we're just trying to avoid this. We're trying to avoid looping through the same elements. And right now you're trying to talk about optimizing on some little thing when you haven't even solved the problem. This is what basically kills people 99% of the time. You haven't answered the question of how you're avoiding the 2 elements. Notice that I said, oh, I need to move up this pointer. But you never answered the problem. You haven't even solved it. You can always optimize later, but optimizing prematurely is basically what kills a lot of code bases and a lot of engineers. So I'm trying to get you not to do this.
Okay, so
let's go back to the original objective. I want to avoid traversing over the same elements over and over again. How do I do this? Just a simple, naive, dumb way of doing it.
Simple, naive way to do this. I'm just a little bit confused. You want me to do the most naive approach, or what?
The most naive way of avoiding this repeated traversal.
Okay. Going back to like, I can find like, it's down 2 pointers, right? Again. Okay. Like, smaller window where it contains all the elements.
Okay.
So, yeah, for example, 2 and 5 is inside the set.
Okay.
Then I'll move to 2 again here.
Okay.
I can move straight to 2. And then that thing, I don't know if I'm being clear here.
Okay, so you found 2, 5, 2. But you haven't found. But we need a 4, right?
But now I need a 4. Okay. Oh, yeah. Okay. If I found a 2, yeah. I was trying to optimize again.
Mm-hmm.
So I'll go to 4. Okay, and now I have 2, 5, and 4 that are like my set.
Okay.
And what can I do is, let's try to see if
let's
to the next.
Let's pause there, quick. So I want you. The reason why I'm doing this is because I don't want you to get overzealous with this. Let's write down what we did here. So all we did was just simply look at all the indexes of the elements in the set. Start, and then just like start at the first index, and then get more indexes. I was say in order, right? All right, we get more indexes until we have at least one of every element in our set. Okay, this works. So this works. So then that works. So now we're not iterating over a bunch of useless elements. Now we're at a point where 2, 5, 1, 2, 4, right? And then we can do 5, 2, 4, or 5, and then 2, 4, 5, or whatever. So.
And then to move the first pointer, don't go to like elements that doesn't make sense. I'll go to the next index that is in my set. For example, if I have a 3 right here, which is not inside my set.
Okay.
Then I found a 4. Let's say.
Yes.
I'll move this pointer not to 3. I'll move to 5.
Mm-hmm.
Then I'll start all over again.
Yeah.
No, not all over. Like 5, and So that was my logic.
Yeah, but you notice here how we grew it, right? So now get more indexes until we get to each element in our set, and then instead of repeating and starting over at 5, 2, 4, if we really want to break it down, and say what is inefficiency? What is inefficient? And still traversing over similar sets. So for instance, the thing you mentioned here.
Hello, can you hear me?
Hello, I can hear you. I'm just writing all this down. So notice here, what is inefficient about this? Oh yeah, we're still doing this crap. So now now we just only move up the pointers.
Yeah.
Yeah. So you see here simply just going step by step and building off of your current solution is going to get you to the problem a whole lot better than just trying random stuff.
Mm-hmm.
That's the lesson I want to take away from today.
Okay. I should have go more step by step way, right? And not just Okay.
Yeah. When you say logically, to me, like trying random solutions is not logical at all. There's very rarely a time when you need to start over, and that usually only occurs if your fundamental approach is very faulty. But to me, I thought that it should have been very clear that there was there's different ways of doing this problem, and that there's still many different ways to go forward. Instead, you just kind of like every single time you found an inefficiency, you just scrapped your solution. And you just end up trying random shit. That was the thing up here. But notice, like, if you look at the way we grew, we do the solution. It's like, how do I get the locations? You know, like we start off with a break the string to get for every single word in that list of strings. Traverse the list, and then you know, keep finding the what's called until we get every single element in the set, right? And then just do that for every single word in the list. And then the next thing is like, okay, how do I optimize it? I'm looking over too many words that don't do anything. So all I need are the locations at which the indexes are in the set. And so, okay, so then how do I generate that? I just need to iterate through the string and get all the indexes to record the elements in the set, right? And so after that, it's like, okay, what's still inefficient? We are still trying to grow it even from each one of those indexes. Like I showed, like 2, 3, so 2, 5, 2, 3, 5, 1, 2, blah, blah, blah. And then we're only looking at 2, and then 5, and then 2, and then 4. And so now we only need to look at the indexes of the valid elements themselves, because we don't care about 3, we don't care about 1, we don't care about 3, right? Yeah. And so that brings us to our 2 pointer, and then now we realize, like, you know, 2, 3. If I look at 2, 3, 5, 1, 2, 3, 4, and 5, 1, 2, 3, 4, this is just looking at the exact same blocks over and over again. So how do I fix this? 2 pointer. There you go. And then, of course, there's still some left to do in this problem, and I'll leave this for homework. So I want you to do this for homework.
Okay, I will. Yeah.
But I want you. What I want to take away from this is that notice, like, at no point did we just like try random shit. We just built on existing solutions and just made it better each time, and doing it piece by piece.
Okay. So. I was just trying to differentiate between like I was able to drive on naive approach. I should have I was just trying to new approaches, which killed me again.
Yep.
Okay.
Yeah. So you abandon your existing. You recognize the inefficiency, but then you just like scrapped your solution. It's like, what's the point then of building on inefficient solutions if you're just going to completely abandon it?
It was not so clear for me, even though you mentioned that was the clear path, right? The clear way to do. That was not so. Yeah, that was like more. Let's say was not so much of more intuition of like, okay, I should consider this and putting the constraints, not like building up, which would make my life much easier in terms of creating the answer.
Yeah. I mean, this is a more long-form problem, and we're closer to what you'll see on, like, the on-sites. But you basically need to be able to build on your existing solutions. I mean, to be fair, like, any of the homework problems I gave you are basically just that on a smaller scale. This is just doing it over and over and over again, and just for a longer period of time. But it's still the exact same principle. It's like, look at the existing solution that I have. What's inefficient about it? How do I get around that inefficiency? Okay, it's still inefficient. What's the next thing I need to fix about it? What's the next thing I need to fix about it? And you should already be thinking like this already, so.
As I mentioned to you, like for some questions, I can do this very good for the one to invert. But there are some questions, I follow, I was trying to follow this. I identified the inefficient. But I think for sure, I skipped steps, which I should have like, okay, am I going too far? Or should I just answer smaller questions before I go to a big picture? I think,
How does this relate to what I've done before? If you can't answer that question, then chances are you're just doing a random jump. It may or may not be the right thing to do, but you should already be able to answer this. How does this relate to what I've done before, and how does it improve my existing solution?
Okay. I didn't ask this while solving.
Yeah, I mean, it's part of building the existing solution, so Let's see. Let me compare. Did I write that before? I mean, did I get general pattern, possible combinations, valid. Yeah, I don't think I've written it before.
No.
Okay, that's fine. Yeah, don't do things in your head. Naive solution, test it out. Yeah, focus on one thing at a time. Okay, that's fine. Try normal case. Okay, yeah. Good. Pseudocode, where am I going to go die? Good. Okay. Yeah. Also, one other thing I wanted to mention is that I felt like a lot of times you were very much married to your example. I noticed this kind of like when I was doing the notes for you. I think that for what you do is usually you try to come up with a solution for that specific example and then patch over it in order to try and fix and allow for other examples. I don't think it's necessarily wrong in and of itself. It's just wrong in the sense that if you thought a little bit more about how it could be more expansive in the beginning, it would be better.
So you mean for me to try like more examples before like adapting my answer along the way?
I don't want to.
Is that right?
I would say more like, how does my solution not only solve this example, but other potential examples? You know, it's a little bit of a art to try and do that because I don't want you to like try injecting like really weird examples, but I want you to try and think of like the next possible step. Like if I inject, you know, like those times when I put in another word or something. That was a very simple, easy to understand. Hey, this is like something that can go wrong with it potentially. There's a small art to it.
Write anything down, right? Okay. Because, yeah, I feel the same. Sometimes I come to one example and then, yeah, I try like, only one more. And then while solving, I see that there's one example I haven't tested.
I don't want to. I only really want to focus on the growing the naive solution for now, because this is something that's going to take a little bit longer. Because it's a lot more intuitive of like optimizing your steps, but essentially what I want you to start thinking about is not just like what can go wrong, but also how can I cover a little bit more, just a little bit. Like what is the obvious thing that's going to kill me, if I keep going through with this. It's that one I don't want you to focus too much on. I really want you to focus on building on existing solutions, because once you do this, then I think it'll come naturally. So don't worry too much about it. It's just something I want to point out that I think you're a little bit too married to the example. So
okay,
don't focus too much on it. I'm just gonna put a note here to maybe discuss it next time or something. It's like.
Oh man, let me just address one thing here.
Yep.
While you were saying like, okay, we have the elements. Now, what can we do like to identify the indexes of the elements in the set?
Yep.
I thought about this, and I don't know if you perceive. I even said, but I said as well. I don't think that would help. I think in that point I should, at least let's see what this can help me. So that was one thing I noticed that I did. Yeah. Which if I move forward, let me put the indexes to see where those indexes can help me. Well, would help me. Yeah.
Yeah, you might have addressed it, but you didn't do anything with the idea, so it's just as good as that.
I didn't. Yeah.
So, but the thing is that the second part of that is that it's not just like what you're doing, but why you're doing it as well. That's just as important. So in this case, you basically said, "Hey, I think I have this idea of trying out my indices," but the problem is that it just came out of nowhere. So, in other words, you randomly come up with this idea means you're also just as likely to abandon it because you have no basis for coming up with the idea.
Why I need this? Yeah, I understand this.
Okay. Yeah, so it's like what I'm really trying to get you to do is focus on why you're in the place that you are. Does that make sense?
Yeah.
And if you can understand why you're in the place, it makes it a lot easier to improve.
Okay.
Okay. So it's 25 minutes. I don't think we have enough time to do another problem. We can do one of two things. We can review other problems that you did, or we could just discuss your homework and I can let you go early.
Okay. Can I just show you like some problematic ones?
Sure. I also want you to try and also include some like time space complexity in your other solutions as well, when you do them. Okay.
Okay, great.
Yeah. So go ahead, show me some other stuff as well that you think, especially if you think you've done this mistake before, show it to me.
Yeah. This is what I'll try to find.
Okay.
A minute. Yeah, I think that one.
Which one is?
On the line, on the row 58.
Row 58. Okay, let me get your sheet out. Practice diary 58. Cool. Reverse all the words in the sentence. That's the one you said you thought you did well on, right?
Yeah, but while you were talking, I thought that was not so good because I made a big leap without growing out my idea, you know. So let me just send you, I think, the file. Just a minute.
I think you sent me the picture of you doing it already.
Yeah. And the picture, I guess, is good. It's on the picture.
Yeah. I saw that. I think you're fine breaking it down. It's just the next step of like, oh well, how do I what is more inefficient? Well, the inefficiency is that you're using an extra array. Can you do this in place?
Yeah.
And so go ahead.
That was the thing. No, that was the point. Yeah.
Yeah. It's recognizing that inefficiency and building on top of your own solution. It's very simple. Okay.
See if there's other.
Let's see what your study schedule looks like.
Oh yeah, there's one, but I think was more with, I don't know, maybe the state of mind. I don't know. The problem called look and say problem. It's it's pretty simple once you understand. I was able to create a idea pretty simple, but I was not like I asked the questions. I even read the ebook again, like the part you mentioned for me to read, and I was not understanding like the first step. You know, the priority 0. That is to understand the problem. I had to read. Like, I had to just kept staring at the problem around like 8 to 10 minutes, and then finally something clicked on my mind. I solved the problem.
That's fine.
Fast, but I don't know why sometimes this happens. You have like I don't know, maybe try 10 minutes later and go to another problem when you completely stuck. Yeah.
If I can't understand the problem, usually that means it's poorly worded, and I'll be the first to admit that I really suck at this first part. I'm trying to understand the problem and all its dimensions. And it's something I can get better at. But usually when there's an interviewer, if I can get around this problem by simply saying, hey, well, this is the way I understand the problem. Let me do an example. Literally by doing the example, the interviewer can say, hey, you had the right idea, you had the wrong idea. That's why I say do examples as well. It's kind of hard when you're doing it on your own, but literally doing an example and just trying it out just kills 2 birds with 1 stone.
Yeah, and once I understand the problem, it was pretty easy because, okay, there's a pattern here. I did the same thing as you mentioned. I to fit this in a pattern. And was like, the approach led me to the right answer. Yeah.
It's like a lot of these tricks I'm describing is literally just me because I am not that smart. I don't have like good instincts for all these naturally. I have to understand why I'm doing it before I make it a instinct or habit, because otherwise I won't do it, and it's just like going to be random to me. So it's like if I don't understand something, then I won't do it. So there's like all these things are like tried and true techniques that'll help you. So if you understand why it's there, then it's a whole lot easier to implement. So don't worry about like not understand the problem for a book. It's like as long as you try to do it and you did the proper steps to doing it and you tried understanding it or like in a bunch of different ways, then you're on the right track. But notice like what you said. You said it took you like 7 minutes to understand the problem, but after that it just was very easy to do. That's the goal. That's good.
Yeah.
That's very good.
Yeah, that was the thing, and I was even thinking, man, it's like step 0 again, you know. But yeah, was the thing, and I just let me see if this problem is put in other words, and I search on LeetCode.
Yeah.
It said you don't recommend, and yeah, it's the same prompt, but a lot of dislikes. I guess it's like they put in a different phrase, you know.
Yeah. Yeah, phrasing is the issue. There's no. I would say that step 0 is unavoidable because if you can't understand the problem, how can you design a solution to it?
Yeah, for sure. I will be designing a non-workable solution.
Yeah, exactly.
And I have just one question for like my schedule. You know, for the things I have to study.
Yes.
I'd say that the strings one. Okay, it's. I had this trouble for sure. I'm gonna work on this, to become a habit. But do you have like other than I guess you address BFS? No. On binaries? No. Yes. Modifying binary. Modifying binary search. Do you have anything else?
I would say do arrays as well. Okay, so let me ask. So looking back at all the stuff I've recommended you from EPI and grokking. What have you completed? What have you not?
From grokking and API, right?
Yes. I'm looking at the sheet. Did you finish recursion and binary search tree? I believe, right?
Binary search tree, no.
Okay, so you
because
still have problems left.
You mentioned. Yeah, there are because I found to give a focus more in recursion since I was struggling more.
Good. Okay.
And I did I think 5 exercises of binary search trees.
Okay.
And I'm in the 7th. No, actually in the 9th exercise of strings. I think I'm gonna finish this pretty quickly, I guess.
Okay.
Like in a good way, right? Yeah. And I think I can finish binary search trees also. And as you mentioned, I guess arrays, right, will be the next thing.
Okay. Yeah. So arrays will be next if you don't have. So it's like if you get done with it. Otherwise, I'd rather you finish up all the previous week's assignments before you move up to this.
Yeah. And just one thing. Do you recommend me to do like again the pattern of two pointers? Because today was not like so second nature to me.
Yeah, if you couldn't, I would say sliding window and 2-pointer if you really need it.
All right. Okay. So yeah.
So let's prioritize that because the 2-pointer should have been very obvious. So do the whole exercise of like what's called analyzing under what conditions you can use it, and I want you to do a write-up for it.
Write-up? I mean.
For the pattern, like when can you use it? When can you not use it? What happens if you try misusing it? All that.
Gotcha. I will do.
Okay. That should take you till the next week. That's a lot of work, so I'm not gonna be surprised if you don't finish it. To 219 to 226. And then like ideally, I would like people to do 2-pointer and sliding window alongside array. So do the grokking, and then after you have time, array. That'll take you to 226. Our target date is 3/11. I don't think you're gonna be ready by then.
About this date. I think I sent you the message. The recruiter of Microsoft, he said to me that they gonna postpone, right? Because they had a problem for probably for the second week. But he said that he gonna keep me posted about this. I asked to one friend of mine that interviewed at Microsoft in the same time for Latin American positions, right, to the US. It's like a different recruiting thing, and they do in the same type of the year because of visas and stuff.
Yep.
He said that all the process happened to him in March. So the first phone screen was around the 3rd week of March, and like the on-sites were on April. So that was the timeline that has been repeating during the last years.
I want
just to keep you posted about this.
Okay, I want to say, like, based on what I'm seeing, you're still a little ways off. I would try probably putting this at 318 or 320 or 326 or something like that. For now, so I'm going to say right now this is based on like what I saw, this is slightly in danger, but you don't have to, if the Microsoft Recruiter comes at you, just give them like I would say 318 or 324 or 324 as the date. If you had to make it, but right now don't make a commitment.
Okay, great.
Okay, I really want. I still think we're still quite a ways off, but yeah.
Okay.
So that's the homework. Hopefully you still have keep it with the schedule. Yeah. Any other questions?
No, I don't think so.
All right, sounds good. Then I guess I can give you time back. You have the homework. You have everything you need to do.
Okay. And this, just one thing, just to let you know, because I think it's good. For the weekends, on this free time on the afternoon, right?
Yeah.
That is 3 hours. I wake up 1 hour later.
Okay.
Then I don't use this time because there's no. That doesn't make sense to me. I prefer to sleep a little bit more, and like stay the start of the morning and the whole afternoon and the night study. I think it's better for me.
That's fine. As long as you're okay with that, then let's do this. Weekend, I'll give you an extra hour to sleep in. Is that basically how much you sleep in?
Yeah, I think it's good. Yeah,
okay,
because
so then, yeah, cool. As long as you don't take the time, then we'll just I'll blank it out. I'll keep this in here just in case, so that way you can put like lunch and shit or whatever.
Okay.
But it's just there for flexibility. I don't want to full commit to it. But if you feel like you want to study during that time, have at it. All right. Is there anything else?
I think that's it.
All right, cool, man. Then I'll see you on Tuesday.
See you on Tuesday.
All right, bye-bye.
Bye.
Okay. Yeah, let's see what you guys said in the comments. Love your channel. We are also lucky to have you making these videos. Thanks, man. I think I focus more on like streaming the coaching sessions more so than coming up with like video essays. I kind of feel like the video essays are more just frosting on the cake because they kind of take a little bit long time to produce. And I only really put them out when I think there's something that needs to be said. But I think between all my current content, I think that anyone at the L3, L4 level can really benefit, even the L5. It's just that I haven't seen a need from my audience for that kind of content recently. It's like those ideas are supposed to help you throughout your career and deliver projects. So if people start like coming to me with like career questions and career like consultations, I'll have a little bit more temperature on what I need to give people in terms of content, and that makes it not a whole lot easier. So if you guys have like any career consultations or anything that you want me to talk to you through, let me know, and that'll help me like produce like some content at least for my channel as well. But overall, I think like most of the ideas that I have in my head are actually out there in the like channel. There's no need for me to like remake videos necessarily. I mean, there are some earlier videos that I think I would like to remake, just because like the quality of like what I do has changed. So I think I'll definitely I can do that in the future. So yeah, if you guys have like any questions about your careers and stuff and how to deliver projects, or you feel like you're messing up, feel free to like book me for some consultation, or at least ask me in the Discord. At least compared to previous sessions, he improved his communication a lot. He was sharing his thoughts on the dog, displaying his ideas, and not jumping into code without a solution. Correct. That's what we've been trying to do. Yeah, he got obsessed with getting a solution by patching his own example. Yep, he got way too obsessed with that because he was trying like random stuff at it. So basically, the reason why I recognized what he's doing was because I've made that mistake myself. But basically, if you don't have a direction or some like heuristic for trying to develop your solution, you're just gonna get married to something that works and then just like try random stuff. In this case, he wasn't building on his previous solution. He was just trying to take a solution that kind of worked and then just like patch and prayed. That's usually a symptom of the guy doesn't know what he's doing. So that's basically what happened. Can you please provide resources for each topic? If you look at my guide and previous streams, I've always recommended grokking the coding interview and elements of programming interview. That's it. Between those two resources, you don't need anything else. And I firmly believe that. So it is not me selling out. You can go back to in like 2 years ago when I was doing this. I recommended the exact same resources. Nothing's changed since then. So I've been offered like to try and recommend some other courses, but to me it's like there's no reason to change a formula that is still just as effective. The only difference is how you view it. Now, if there's someone who can come up with a resource that helps you think effectively about problems like this, I'd definitely be open to like looking at it. But to me, like nothing in the industry right now is like can compete with what these two resources offer if you do them the right way. So that's it. So are there any other questions so far? I'll put a little bit of Dota on since we did end a little bit early. I guess if there's no going once, going twice, 3 times. All right. Well, I guess no other questions. So if that's the case, thank you all for joining me. We will have a stream on next Tuesday at 8 p.m. Pacific Standard Time. We're going to be looking over his replay analysis, and hopefully he is able to follow up on his efforts here. Hopefully he learns from his mistakes, and hopefully he improves on them. So we'll see if that's the case. Thank you all for joining me. Hopefully you guys all learned something today, and I'll see you all next time.